Okay, I'm going to start going over the very first Chapter 2 test in Algebra 2. So let's see if everybody can pick this up. A power raised to a power you multiply. So that's 2 to the third, x to the 9, y to the 6. So 2 to the third is 8, x to the 9, y to the 6 should be the answer. Okay, on number 2, I usually move the negative exponents or subtract them. So I see there's a y squared on top and an x squared on the bottom. I see an x to the negative 1 on top, it will go to the bottom and become positive. I also see a y to the negative 1 on bottom, it'll go to the top and become a positive exponent. So 2 plus 3 is 1, 2 plus 1 is 3, and 2 plus 1 is 3. So hopefully it's just y to the third over x to the third. Does 3 over 9 simplify? Yes, 1 over 3. A to the 3 minus 1 is a to the 2. B to the 1 minus negative 1 is b to the 2. So the answer should be a squared b squared all over 3. You could also think of it as how many more a's are on top? 2 of them. How many more b's? If I move this up, it would become a positive, and that becomes a 2. So there's a few ways to think about it. Definitely should be a squared b squared, right? Because the squared is on the thing here, on the b. Okay, I think we're just simplifying these expressions, yes. Again, a power to a power, you multiply exponents. So it's 3 to the negative 2, x to the negative 4, and y to the positive 2. Any positive exponents stay where they are. Any negative exponents move to the other side of the fraction and become positive exponents. So your answer should be y squared over 3 to the second is 9, x to the 4. On number 5, I'm going to multiply 7.2 by 3.8 and get 27.36. And this would be times 10 to the, when you multiply, you add exponents. So 5 plus 3 make this an 8. The only problem being this has to be between 1 and 10. So if I move the decimal one place, it would be 2.736. Because I went from 27 to 2, I made it smaller. I have to make this exponent bigger by the number of decimal places. I only moved it 1, so I make it bigger by 1. And that should be the answer for number 5. Okay, after 5, we're moving to 6. We want to add like terms or combine like terms. 1x squared plus 2x squared makes 3x squared. Negative 3x is the only x, but then you have 5 plus a negative 1, which is 4. Now 7 is a subtraction. You'd have to distribute this negative 1 or change all your second signs. So to subtract, basically, you change the signs and add. I don't like to call it adding, I call it combining. 3x squared and negative 2x squared is 1x squared. Negative 2x and 3x add to give me 1x. And then you have 15 and a negative 2, which should give you 13. 15 negative 2 is 13. I apologize, I don't have a 15 here. I believe the test had a 5. And 5 and a negative 2 is what I had on my answer key, a 3. So it's really 5 and a negative 2 to get the 3. Okay, after 7, we move to 8, which is multiplication. We don't call it FOILing, we call it distribution. 3x times 2x is 6x squared. 3x times 5 is 30x. Negative 2 times 2x is negative 4x. Negative 2 times 5 is negative 10. Combining the like terms, which are usually your middle two terms, I think that's a 26x minus 10. Apparently I can't multiply because 3x times 5 is not 30. What's 3x times 5 when I do 3x times 5? Should be 15x, shouldn't it be? Making this 11x. I'm going to try and go a little slower, sorry. You could write this out twice and distribute it because squaring it means times itself. Or you could learn the rule where you square the first, you square the last, and then twice the product in the middle. If you multiply, that's negative 6xy, twice it is negative 12xy. Again, the rule is square the first, square the last, multiply it, and double it in the middle, twice the product in the middle. Okay, after 9, we go to 10. We're distributing again. 2x times 3x squared is 6x to the third. 2x times negative 5x is negative 10x to the second. 2x times 2 is 4x. Now, if I do a negative 5 times 3x squared is a negative 15x squared. Negative 5 times negative 5x is a positive 25x. And negative 5 times 2 is a negative 10. Let's combine like terms to get our answer. I think that's minus 25x squared plus 29x and minus 10. So that's how you'd get it through distribution. I'm going to do the same thing on 11, but I'm going to take two of them and multiply it out first. If you're good, you'll know that 3 minus 1 is 2, and you get this. But let's go ahead and see what we have if we multiply these last two. We had x plus 3 times x minus 1. X times x is x squared. X times negative 1 is negative 1x. 3 times x is 3x. 3 times negative 1 is negative 3. Combining like terms, I think, gives me what I have here. So basically, you're just multiplying two of the binomials together first. Any questions on how I did that? Then you're going to distribute here. X times x squared is x to the third. X times 2x is 2x to the second. And x times negative 3 is negative 3x. Negative 2 times x squared is negative 2x squared. Negative 2 times 2x is negative 4x. And negative 2 times negative 3 is a positive 6. Again, combining like terms, let's see what we get. We'd have x to the third. Looks like that'd be 0x squared minus 7x plus 6. So I think you don't have to write the plus 0x squared. And hopefully that's your answer for 11. 12, I apologize. I think I told you to simply write prime because this does not factor. It's a bad question. That happens. Sometimes you do get ones that are not factorable. I just did not wish to take your time, valuable time up on a test. That's why I told you it was prime. Number 13, we want to factor. So how do you get 2x squared? It has to be 2x times x. Most times a trinomial factors into the product of two binomials, two terms. Anyway, on this one, what's a times c is negative 30. Ax squared plus bx plus c. b is negative 1. I need some numbers that will multiply to give me negative 30 and add to give me negative 1. With practice, you'll come up with them pretty quickly. Now, if A is a 1, you could just put them right in here. But because A is not a 1, you have to connect the outsides and the insides, or what's sometimes called the means and the extremes. 2 goes into the negative 6, so I put it up there and I put the 5 here. Now I'm going to think 2 times what gives me negative 6. 2 times what is negative 6? Well, that'd be a negative 3. Then there's a 1 times what is 5. 1 times what is 5? That'd be a positive 5. So now we should have it factored into 2x plus 5 times x minus 3. I usually verify, does last times last equals last? Does 5 times negative 3 equal negative 15? And if it does, I'm usually pretty happy. I think I factored it correctly. You can always check by redistribution, see if you get your original problem. On to 14. 14, we want to factor. Many times, if there are 4 terms, but with no common factors, you might think about splitting it. Can I take an x squared out of the first 2? That would leave me with an x squared plus 5. I could take a 9 out of the second 2, but I could also take out a negative 9. If I take out a negative 9, notice it's still negative 9x minus 45. But now I have x plus 5 in both of them. If I factor out the x plus 5, what would remain? If I take out the x plus 5, these would go away. What would remain? The x squared minus 9. And that's a difference of squares that factors as x plus 3 times x minus 3. Again, that's one of our rules. It is, and it becomes very important, a squared minus b squared factors into a plus b times a minus b. So this is your a plus b, and this is your a minus b. Just like there's a rule for 15 on the difference of cubes. The difference of cubes is a cubed minus b cubed would factor into a minus b times a squared plus ab plus b squared. So x cubed is simply x cubed. But what cubed is 27? 3. So the a is an x and the b is a 3. If the a is an x and I need a squared, I square it. If a is x and b is 3 and I need a times b, what's x times 3? Well, we call it 3x. And if b is 3, b squared would be 9. And that's your factorization on problem 15. Okay, after 15, 16, we want to solve by factoring, I'm assuming. I think I can take an x out of both of these, leaving me 3x minus 1. Does that still give me 3x squared minus x if I distribute? Anyway, if something times something equals 0, one of these factors must equal 0. So x equals 0, or 3x minus 1 equals 0. Add 1 and divide by 3, and you'll have your answers. X equals 0 and x equals 1/3. 17, I think we're going to try and factor this, even though I think we might have already done it in a previous problem if you were observant. A is a 2. What's a times c? Negative 30. What's b? Negative 1. Do these multiply? Whoops. Negative 6 and 5. Do they multiply to negative 30 and add to negative 1? 2 goes into which one? Negative 6 and 5. So again, let's change colors. 2 times what is negative 6? 2 times what is negative 6? 1 times what is 5? 1 times what is 5? Now I have it factored. So it's 2x plus 5 times x minus 3 equals 0. Again, if something times something equals 0, it's called the zero product theorem. You should have gone over that in Algebra 1. That means one of these factors should equal 0. So I either have to subtract 5 and divide by 2. Divide by 2. Or add 3, and I get x equals 3. You'll notice the maximum number of answers corresponds to the degree of the polynomial. Okay, 18 is division. Looks to me like this is an integer. What makes that 0 should be an integer. So I'm going to do synthetic. Are all powers represented? 2 to the 3, I'm sorry, x to the 3, x to the 2, x to the 1, x to the 0. Looks like they are to me. So I can bring down my coefficients. 2, 1, negative 8, 5. Leave a space, draw a line, make a box. The number that goes in the box is whatever makes that 0, which is a negative 3. So 2 comes down, multiply, negative 3 times 2 is negative 6. Put it here and add, negative 5. Negative 3 times negative 5 is 15. Add, I think, gives me 7. Negative 3 times 7 is negative 21. When I add, I get a remainder of negative 16. So if I'm looking to divide this, this is going to be 2x to the 1 less than 3, so it'll be 2x to the second, minus 5x plus 7, plus your remainder over the divisor. So this is what you should have got when upon division. It could have been found through long division also, but this lent itself nicely to synthetic, so that's the approach I took. Okay, I think I may even mention during the test that 17 and 19 are basically the same. You want to find the zeros. So you got to make this equal 0. And this is going to factor. So I need to see how this factors. I believe it factors into 2x plus 5 and x minus 3. Is that what I got on 17? 2x plus 5x minus 3. I'm pretty sure that's how it would factor. Let's make sure. Is that 5x and a negative 6x? 5 and negative 6 add to negative 1. So I do have it factored correctly. So I make this equal 0 and I make this equal 0. And I get the same answers as I did before. Subtract 5 and divide by 2. And if x minus 3 equals 0, you'd add the 3 and get x equaling 3. These are your two answers for 19. Now 20, you can't just split it. There's no common factors. So we might have to try synthetic. So I'll bring down 1, negative 5, negative 22, 56. And we're going to have to try it until we get a remainder of 0. I could try 1 and negative 1, but I'm not sure that they're going to work. I told you try the small numbers. So let's try 2. Does 2 go into 56? Yes. So it's a good one to try. Bring the 1 down, multiply. 2 times 1 is 2. Add is negative 3. 2 times negative 3 now is negative 6. When you add, you get a negative 28. 2 times negative 28 is negative 56. And you do get your remainder to be 0. So what this means so far is f of x equals, well, that'd be an x minus 2. This is an x squared minus 3x minus 28. And I need to see if that factors. Are there factors of negative 28? that add to negative 3? Well, how about negative 7 and 4? Do they multiply to negative 28 and add to negative 3? So if I'm looking for zeros, that means I want to make this equal 0. So what makes that 0 is 2. What makes this 0 is 7. And what makes this 0 is negative 4. So we found all of our zeros. Anyway, I hope this helps. If you're preparing for another retest on this, good luck.